In this video, let's talk about the binary search tree in order traversal. We want to traversal the binary search tree with in order, and we want to do that with recursive way and iterative way. For example, this is a binary search tree. We want to first visit left, there's no left. Then we visit the current node. Then we visit the right branch with left, then current, then right. So finally the output is 1, then 3, then 2, then 4. How to do that recursively and iteratively? Let's take a look at a diagram. Here is our binary search tree. In order to do that recursively, we just code as we describe. We first recursively visit the left branch, then we visit the current branch, then we recursively visit the right branch. After that, we just finish the in order traversal. So take a look at this diagram. For example, our first we pass in root 9, and we check is this root is null. If not null, then we first visit the left node, which bring us to this node. At this node, we check is that null? No. Then we visit its left, so that bring us here. Again, it has go into this line, and we visit root left, which brings us to this node. At this node, we check is that null? Not null, so we run this line. Root left is null, so we are done with that. So we add the 1 into our final result, and we run this line, which is bring us here, which is null. So that bring us here. Here the right node is null. It returns bring us to the end of this line, right? End of this line, and we return, which bring us back to this line, and we just finished around the left and bring us back. We add 2 into the final result, and we run this line, which brings us here, and we add we pass in left node, which is null, and then we add 3, then we pass in right node, which is null, and we return. So once we return, we just finish running this line, and then we go back. Once we return, we just finished the left branch, right? We just finished the core of this, and then in order add, we just add 4 into the final result, and we run the next 9, which bring us to this node, and then we recursively we add this node. So we will run this line, root left, which brings us here, and we will run root left, which brings us here, and we add left is null, so we add 5 into the result. Right is null, so we return. We just get out of here, and we add 5 into the final result. Then we go around this line. At 6, there is no right branch, so we finished. We return, which brings us to this node, 7. After add 7, we run this line, go to the right, which brings us to this node. After we added 8, we just finished adding this whole right branch. So we just finished running this line and return back to this node. So we added 9 into our final result, and then we run this line, which brings us to this node, and run root left. There's no left to add, so we just add 10 into our final result. Then we run this line, which brings us to this node, and we run root left, which brings us to this node, and we add this node, and then we add 12. Then we run this line, there is no right node. So we are done with this right branch. And then we just finished printing out the whole binary search tree recursively. Okay, as we do this exercise, we can see we don't print out the we only print out the elements when we reach the leftmost node. Then we just add this to the final result. Then we trace back, right? This is our we go the leftmost node, then we trace back. While we trace back, if there's any right node, we will visit the right node, and once we exhausted all the right node, we will go back. We will continue trace back. Whenever there is a right node, we will visit the right node. But when we visit the right node, we are not adding this right node immediately. We will first traversal to the leftmost node, then we add that to the stack, then we trace back. So this is how we do that. We first find the leftmost node, right? And we will pop out the element from the queue. After we pop out the element and added the value, we will check its right node. If there's any right node, we want to add all the right nodes left branch into our stack. After that, we will pop out and we check if any of the nodes have the right node, then we'll add that. So this is an iterative way. Let's use this diagram as example. Here is a stack. We pass in root, right? Then we trace down. While we trace down, we push all the elements on our path into a stack. So 9, then 4, then 2, then 1. Now there is no left node, so we are done. And we go into this while loop, and we pop out 1. We pop out 1, we add 1, and we check if this node have the right node. There's no right node, so nothing to do. We go to the next loop, we pop out 2, and we pop out 2, we add 2. We check if 2 have any right node. Yes, there is right node. So we just go to the right node. Since this right node is not null, let's push 3 into the stack. And there's no left node for this 3, so we just get out of this while loop. Let's pop out another element. In this case, let's pop out 3. We pop out 3, we add 3. We check if 3 have any right node. There's no right node. That's great. So we go pop out another element, which is 4. Okay, we pop out 4. And after add 4, we check if 4 have any right node. Yes, there is right node. So we get this right node, but we won't stop here. We want to add all the left branches of this right node into the stack. So we first add 7. And we check if the 7 have left node. Yes, there is. So we add 6. After that, we check if 6 have any right node, left node. Yes, there is, so we add 5. And 5 have any left node? No, there is no left node, so we are done. We go out of this while loop, and we go back here. We pop out another element, which is 5. We pop out 5. We add to the result, and we check if 5 have any right node. 5 don't have right node, so we are done. We pop out another node, which is 6. 6, we check if there's any right node. No, 6 don't have right node. We are done. So we pop out next, which is 7. 7, we check if there's right node. Yes, there is right node, which is 8. Let's add 8. We haven't done yet. We will check if 8 have any left node, but 8 don't have any left node to add, so we are done. We go back. We pop out another element, which is 8. let's pop out 8. 8 is done. And let's pop out the next element, which is 9. We pop out a 9, we add a 9, and we check if 9 have any right element. Yes, there is, which is 10. Let's add a 10. And 10, we check if 10 have any left branch. No, there's no left branch, then we are fine. So we go back here, we pop out 10. And after pop out 10, add a 10, we check if 10 have any right node. Yes, there is, so let's add it 12. But we haven't done yet. We will check if 12 have any left node. Yes, there is, which is 11, so let's add 11. Then let's check if 11 have left node. No, there is no left node, so we are done. We go out of this while loop, we go back to this level. Let's pop out 11. After pop out 11, add 11, and we check if 11 have right node, which there's no right node, then we are done. Let's pop out another element, which is 12. 12, let's check if there's, after add it, we check if 12 have a right node, there's no right node. We are done, so we go back and we check the stack is empty, so we just finish the loop. And as we see, the order we added a result to the final array is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is in order traversal.